Hello, good morning everyone. Welcome all of you to my online physics class. Hope all of you are well by the grace of Almighty. Already we have finished the theoretical part of chapter 9. The name of this chapter is Reflection of Light. So, in this lecture, I will discuss about sample creative question and its solution. Okay, so let's see today's sample creative question. So, dear boys, this is our today's creative question, and that is our stem of this creative question. Here, light ray is incident from the glass medium and refracted to the air medium. Okay, and here the incident angle is 28 degree and the refracted angle is 45 degree. Okay, and the questions are: question number A, write down the Snell's law. Question number B, explain perceptions of colored object. Question number C, what will be the velocity of light in glass? Okay, and question number D is, the refracted ray will go towards the plane of separation for what change of incident angle analyze mathematically. Okay, here you see that this line is the separation line between glass and air. Okay, so let's student, we will solve or calculate this creative question step by step. So our question A is, write down the Snell's law, and the answer is, for a fixed pair of medium and for a fixed color of light, the ratio of the sine of the angle of incidence to the sine of the angle of refraction always remains constant. This law is called Snell's law. Mainly, the second law of refraction is known as second law. Okay. Our question number B is, explain perceptions of colored object. Okay. So the explanation is, an image is created on retina by our eye lens. Rod and cone between these two types of cells that go from retina to brain. Cones are color sensitive. There are three types of cones: red, blue, and green. No matter how many colors an object has, our eye detects it with these three colors and sends information to brain. Brain then, with some special process, differentiates these colors, and this is how we experience colorful objects. Okay, so this is the explanation of perceptions of colored object. Now we will calculate the question of C. Okay, here we need to calculate the velocity of light in glass medium. Okay, here from the stem we have given that the angle of incident I, which is denoted by I, equal to 28 degree. Okay, angle of refraction R, this angle is called refractive or refracted angle, and this is denoted by small r, and that is 45 degree. Okay, and we know that the light's speed in air Ca equal to 3 into 10 to the power 8 meter per second. Okay, and we need to determine the speed of light in glass. Cg equal to what? Okay, so we know from the definition of refractive index, here we can write light is passing from glass to air. Light is passing from glass to air. You should very careful about this term. Light is coming from or going to. Okay, this is very important for calculation of the mathematics of light. Okay, here light is coming from glass and refracted to air. Okay, so here the refractive index is GNA. Here this is called the refractive index of air with consider glass. Okay, refractive index of air with consider with glass equal to, we can write sin I by sin R. Okay, sin I by sin R equal to Cg by Ca. Here Cg is the speed of light in glass and Ca is the speed of light in air. Okay, so now we can write Cg equal to Ca into sin I by sin R. Okay, so putting the value of this parameter, here Ca is 3 into 10 to the power 8, sin I, here I is 28 degree, sin R is 45 degree. So putting the value of this parameter and calculating, we get the speed of light in glass Cg equal to 1.992 into 10 to the power 8 meter per second. Okay, so boys, you should very careful about the unit of this math. Okay, all math, especially all maths. So here the speed of light in glass is 1.992 into 10 to the power 8 meter per second. This is our answer for question number C. Now we will calculate the question number D. Okay, here we need to determine that if the reflected ray will go towards the plane of separation, then what change of incident angle analyze mathematically. Okay, here this is our moderate figure or change figure. Here for what angle of incidence we don't know, the reflected angle will be 90 degree. Okay, from this question we can draw this picture. Okay, so here in this case, if refracted ray passes along the separating surface, then here the new refracted angle R prime equal to 90 degree, and in this case angle of incident I prime equal to what? Okay, so we know that the refractive index of air consider glass equal to, for this case, okay, equal to sin I prime by sin R prime. Okay, then sin I prime equal to GNA into sin R prime. Then we can write GNA equal to 0.664 into sine 90 degree. Okay, here the value of sine 90 degree, we know that the value of sine 90 degree equal to 1. So the value is 0.664. Then inverse of sine, we need to determine the incident angle for this case. So here the incident angle I prime will equal to the inverse sine of this value, and after calculating we get 41.61 degree. Okay, so we can say that if the incident angle of this case is be 41.61 degree, then the refracted angle will passes along the separation line of these two medium. Okay, so now we need to calculate the change of angle. Okay, so we need to calculate the change of angle. In our main stem, we have given that our incident angle was 28 degree, and in this case our incident angle is 41.61 degrees. So the incident angle should be increased by 41.61 degree minus 28 degree, or 13.61 degree. Okay, so we can say that if angle of incidence is increased by 13.61 degree more than before, it will pass along the separating line between the glass and air. Okay, so boys, this is the answer for question number D, and this is all for today. In our next lecture, we will try to solve another creative question. Until then, thank you boys.